Hello, we're the ASU Solar District Cup team, and this semester we are working on improving our district use case for the University of Nebraska-Lincoln. So this semester we're doing our refinements to our solar design, as well as the implementation of a battery into our solar and storage system. And we're also trying to improve our financial model by doing different methods of tuning and different programs that I will have Andy talk about in the next section. So Andy, I'll pass it over to you. Thank you.
Thank you, Nick. In this semester, the Solar District Cup organizer is asking us to gain insight with the operating strategy and the economic viability of a solar PV and battery storage system. At any moment of the day, the electric load demand needs to be balanced by the energy purchase from the utility or energy coming from a solar PV or the stored energy from a battery. The PV can only generate when the resource is available, but for the storage, we need to decide when to operate it. So in each hour of the day, there is a decision to be made about whether to charge, discharge, or do nothing with the battery. If we decide to charge or we discharge, then we need to know how much. By using our engineering skills and applying a battery optimization software tool, we will identify the size of battery and a dispatch strategy that makes best use of the PV and battery storage system. A major consideration for the installation of a battery is whether it can provide enough cost saving over the life cycle of the system or not. And so to be sure, we are investing in the right technology and save money for our customer. My colleague Part 1 will tell you next how to develop a financial model for this integrated system. Thank you. And I'm handing over to Part 1.
Thank you, Andy. This semester, we are focusing on restructuring solar PV system financial model from the last semester by incorporating battery storage system. More importantly, we are doing an in-depth analysis of annual cost savings to justify new PPA price within the desired internal rate of return we would be going to offer for our district use case, the University of Nebraska-Lincoln. The current electric energy tariff will be studied to determine the dollar value of energy savings that can be realized by peak demand shaving during winter and summer. SAM solar financial tools will be used for financial modeling and analysis of cost savings. Izaka, my colleague, now will speak on environmental goals for this semester. Thank you. Over to Izaka.
Thank you, Part 1. Obviously, the environmental impact could not be ignored in this type of project. While there are no global warming emissions associated with generating electricity from solar energy, there are emissions associated with other stages of solar life cycle. Based on life cycle environmental impact assessment, this project scale lithium battery storage has significantly lower impact than natural gas power. Depending on what type of material battery are made, manufacturing also affect the battery carbon dioxide footprint and climate impact. Lithium battery contain some toxic material which could impact the environment, which could impact the environment if there's a linkage. This project involves some underground work because many cables will be pulled underground, which requires some digging. I will pass it over to James.
Thank you, Izaka. Most of the work has been completed in the first semester. So with the remaining time, we are focusing on refining our existing design, adding a cost-effective battery storage system, and financial model that creates value for the university. We are reviewing the existing roof-mounted PV system as the previous design did not deliver the desired potential savings. In addition to this refinement, we are exploring the environmental impact of the battery storage system, including carbon emissions, mining practices, and researching the use of recycled materials in our battery design. We believe these changes will add value to the campus, increase potential savings, while also showcasing the desire to reduce the environmental footprint. Thank you from ASU Solar District Cup team.